we're done with our class.
What is up? Pre-Cal 12, we're here in a study session. We've got a lot of people here. There's so many people. They're banging down the door.
Packed, y'all.
Yeah, let's go. Let's get this started. So hopefully this is helpful for y'all, and let's get this show on the road. I want to start with one, but then y'all can give me. Oh, I forgot the shot. Hold up.
Forget the shot.
I don't do that for Pre-Cal 12.
Whoa, chill. So we're not equal. That's what you're saying.
Just something, I don't know.
That's
Something
what
I
you're
always
saying. We're not
do.
equal.
That's right. I always do the inaugural shot. Here we go.
Oh. Have you ever
Been
made it
sick.
before?
Oh yeah, on the video live.
Are you serious?
Oh yeah,
I made it on the video live too after that.
you did. That was pretty impressive.
That's because y'all are the same height, so we're like.
And short jokes are being fired here early on in the podcast. All right, here we go. The first thing we're going to do is change number 9 to y to the 4th and y to the 3rd. Okay? The reason why we're doing that is it helps us to identify what term that we're looking for. The reason why I want to start here is I think this is one of the more difficult ones. We kind of did it in class, but this one kind of brings just a little bit of something different there. We'll do the second one. Okay? So this says determine the coefficient x squared y to the 3rd and the expansion of, and then it gives us the following binomial. Now, how many terms are there with 3x plus 2y to the 5th? What's to the 5th power? What would it be? It'd be 6 terms, yeah. So we would say, we would just put 6 terms, 3, 4, 5, and 6. Now, if I were to plug this in, would you agree that this would be a to the 5th, right? A to the 4th, a to the 3rd, a to the 2nd, a, and then nothing, right?
Yeah.
The other way would be b to the 5th, 4th, and technically I could just keep going. I could actually just expand it this way, but it doesn't say that. It just says find the coefficient with the term of x squared y to the 3rd, okay? So now I'm going to say if I plugged x in for a and y in for b, really what I'm doing is I'm plugging 3x in for a and 2y in for b. Do you see that?
Yeah.
Okay. Now, there's kind of 2 ways that you could do this. The one way is what term here matches up to x squared y to the 3rd? The 4th term, right? You see that?
Yeah.
So really what they're wanting us to do is they want us to find the 4th term of the sequence.
Okay.
Now, how do we do that? That's that formula that you could write down, where you're just going to put n CR, x to the n minus r, y to the r.
Oh,
But-
yeah, I missed that formula. Are we gonna have a formula sheet?
That same formula sheet, you could write that down on there. That's fine. You could actually use the same one. So just write that down. Remember, n is the power that's there. And r would end up being the term minus 1. Okay? So n is I got the power.
So wait, N,
And r is the
C,
term minus
R. Is that C supposed to be big?
1. NCR, yeah, the C is big. This is the calculator part. The NCR part is the calculator part. And then x to the n minus r and y to the r. The nice part about it is we know what x to the power of n minus r and y to the power of r is going to be, right? What is it? Well, it's already been stated, right? X squared y to the 3rd. But we can show it just in case you need it. So the power up here would be to what power? What is the whole thing to?
5th.
The 5th. So we got 5 as n. And what is the term minus 1? 4th minus 1, which would be 3, right? So we get 3. So this will be, does that make sense
Wait,
for
where
y'all?
we get that 4th minus 1?
Because this was the
fourth term.
4th term, and then minus 1 would be 3.
Okay. Wait, so we're still finding the 4th term, but
Yeah, just still finding the 4th term.
no.
So this would be 5 C3. This would be x to the power of n minus r, which is x to the 2nd, right? And then y to the r, which is y to the 3rd, which is the same as what
So
we
it's
had.
just all one formula?
All one formula.
Okay.
So 5C3 is, if I went down here, and I did, Pascal's triangle. You know how it has all those terms and stuff?
Yeah.
That number right there would be the one that would be 5C3.
Okay. So the fourth term will be 5C3.
Correct.
So we're done basically.
Pretty much, yeah. So we just go to, then we just plug it in. That's it.
Wait, did we just do the second one on 9?
Correct.
Okay, so we didn't do the other one.
Mhm.
Got it.
So then we'll go to math, probability, NCR. We'll go 5C, hold on, my fault. 5C3, and then we'll just put 10 in there, okay?
Okay, sweet.
So this is 10. Now what represents X?
The A? Wait, is that what
Mhm.
you're asking?
The A part, which is
3x?
3X, right? Are y'all good so far?
Yeah.
I know this is heavy. I know this is a little bit weird. But we're putting 3X in for X here. We'll square it. And what goes in for the Y part?
2y.
2Y. And we'll make that to the third. So if we square 3, we square X, that would produce what here?
9x squared.
Good. And then if we did 2 to the third and Y to the third, we get
Y to the third.
8Y to the third. So really it's 10 times 9 times 8. Is it not? Like,
Yeah.
just plug that in. Okay, so we'll just go 10 times 9 times 8. So that would be 720. So we would put up here 720 x squared y to the third. Okay? It's a lot, but basically that's how we break it down on that part. Okay? At home, I would start and try number 9, and then hopefully that will be of help to you there as you're going through. Okay? Good, good. Thoughts on other ones? Are there any other ones as you're looking through? Does number 10 look okay? I plus 4.
Yeah, number 10 looks
I
fine
plus
because that's just what we did earlier today, right?
Yeah, we did that earlier. Remember that, this is just for everyone at home. I plus 2 to the fourth means we have 5 terms. And just remember we match that up with Pascal's triangle. A to the fourth, A to the third, right? A squared, y'all got it. Remember, A is going to be the first term, which is I, and B is the second part of the binomial, and that's, our B is 2. Good there? Good stuff. We could just start at number 1 and just make sure we're all good on these. If we're good, I don't want to waste your time, you know? But we'll just start on 1, and if we could, just list what type of formula we're going to use. And if you have any questions on how to plug it in, let me know.
Okay, sweet.
All right, good stuff. Okay, so number 1, what formula are we thinking?
Let's do sum of infinite. Sequence geometric. Sorry, sum
Okay.
of finite, finite.
Yep, sum of a finite because it's to 12. What does 12 represent?
A-N.
No,
A-N.
Not an.
That's it.
Okay, kind of. So it's like S of 12
That's
terms.
12.
It's S of 12. N
Okay.
is what 12 is. Yeah.
Right.
And I think
I
we
knew
were
it had
saying
something.
that.
I knew it had something to do with that.
So 12 would be N. It's nice here because they gave us A1 and then R. Got it. Say it right there.
Yeah.
All right. So that would be A sub 1 times 1 plus or 1 minus R to the N, and then divided by 1 minus R. And we just plug that in.
Right.
Got it. Do we need to go over that more?
And this is still where, like, if it's negative, we do the thing, but if it's not negative, we don't have to do the thing, right?
The parentheses, you're saying?
Yes.
I would
You
say.
suggest that we do the parentheses with the exponent anyway.
I would just do that
Okay, well,
anyway.
I'm about to put everything in parentheses now.
That's fine. I know it's more annoying than anything. It's really the top part that is the struggle. And also doing your alpha y equals will really help too.
Yeah.
That way you can back it up. Cool. David's saying this. Just make sure you put parentheses around it while we put it in our calculator. If you get a chance to, go ahead and double check that on the test. If you especially have time, go ahead and double check it. Cool. You want to go to number 2?
Yeah.
All right, number 2. What type of formula would we use on number 2? Think.
Check parentheses. On number 2, is it geometric? It looks like multiplication. The 12, 1/2. geometric, and yeah, same one.
Good, Victoria. It's going to be the same formula because it says find the sum. 10 terms. What is 10 again?
Yeah,
There's the n.
Good. 10 is our n. And what would 12 be?
12 is the
A.
Good. A1. And then r would be our -1/2. So to David's point, just again, I know we keep saying this, but we have A1 times 1 minus. It's going to be important when we put r in that we really put in parentheses on both on the top because we put in -1/2. So again, that -1/2 does not make this positive until we first take it to the 10th power.
On the test with the 2.
Perfect. Yeah, thank you, Jim. Okay, and we'll plug that in for number 2. First number 2 there. Good. Questions on 2, y'all?
And that's to the nth power, which is 10, right?
Correct. It's to the nth power, which would be 10 here.
Sweet.
Good. Number 3. Are y'all good with continuing if we're
Yeah.
good? I mean, you can kind of solve it, but I want to make sure I help y'all if you don't understand something. Number 3 says A1 steak sauce is 15. The sequence is defined recursively, which is just a fancy way. We'll help you with that if you need it. It says find the formula for the nth term of the sequence. So in order to get to the next term, we're just going to add 2.5 or 5/2 over and over and over again. Okay? So 15 added by 2.5 would be 17.5. Add 2.5, you get 20, and then you just keep going. Okay? Because of that, is it arithmetic or geometric?
Geometric.
Geometric, you said?
Yes. No, sorry, arithmetic. I'm sorry. I'm going all over the place.
5/2. Good. So what would 5/2 be?
The difference.
D. Yeah, that's the D. The R would be the geometric side there.
Bro. See you tomorrow.
All right, so we have our A sub n. See Jared. See you tomorrow, man.
You too.
Is equals A1 plus n minus 1 times our difference. That's the nth term.
And A1 is 15, right?
A1's 15. What would be our difference? We said 5/2, right? And so just as a heads up, that'd be A sub n equals 15 plus n minus 1 times 5/2. Or you could put 2.5. Technically, we probably should simplify this, though I don't know, maybe like a point if we'll see. But technically that is the nth term. But you could also multiply 5/2 to n 5/2. Sorry, that should be 2. And then you could just combine like terms of 15 minus 5/2.
And that's just how we find our n.
Yeah, the nth term. So what that means is, if I said find the 10th term, you just put 10 in for n, and you're good. Okay? Good on 3?
Wait, so is that how we find our a sub n or our n? Like, if we do like to distribute the 2.5, does that help us find our n or our a sub n?
So we don't know, we can't actually find either. Because we don't know what n is.
Yeah.
It just said find the nth term, which just tells me that I don't know what n is. I'm just trying to find a formula.
But like, let's say we cross out the a sub n, and
Mm-hmm.
we just do that 15 plus the parentheses -1 of 5/2, and then just set like it equal to 0, and then find n. Does that work or no?
The only time that would work is if I said the nth term is 0.
Okay.
To find n, I could backtrack and
Okay, got it.
go. But not for this one. Let me give you, for instance, though, one that will, because it's easy. I think it might even be, no, not that one. No. Good, we've already done, I think we've done 9, we've done 10 in class. Just checking those off. Boom. Okay, so like 13, we can go ahead, we can knock 13 out easy. It says write the first 5 terms, right? So if I did that, here's the nth term. What would I do to find the 5 terms?
Just plug in 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Good. Also, you could plug in your calculator. We did this on number right here, number 4 today. I don't know if it was in y'all's class, but n squared minus n to the third. If I just put that in for x squared minus x to the third, right there, and I go to second graph, which is my table, 1 through 8, I can just, it's as if it was plugged in.
Sweet.
So it's easy. That way you just list them out.
Sweet.
Okay? You'd have to plug them all in. But that's just something easy when you're going to plugging in values to get the first 8 terms. So that's just an example of nth term, plugging it in, and going from there. Cool? All right, what about 5?
It looks like, well, the top one was like adding. Well, never mind, I lied. It's definitely multiplication, so it's geometric.
What are we multiplying by?
2.
2, and it also says geometric, which,
Oh,
That
wait, I
helps
didn't even
too.
see that.
yeah, kind of, sometimes it won't, so it's good to know. So I'm multiplying by 2 here each time, right? Multiply by 2, multiply by 2. If it says find the 22nd term, what, in the geometric sequence, what formula would I use there?
Finite?
Okay, did I say
No,
find the
it's-
sum?
Oh,
Good, Victoria. Yeah, we're looking for the nth term, not the sum of. But if I said find the sum of, that'd be good. But we could just put in a sub n equals a1 times r to the n minus 1. Where what is a1?
4.
4. Good. What's r?
2 times 2.
2. And then what is n?
22.
22. Good. And that's to the 22 minus 1. It's going to be a really big number, by the way.
Yeah.
So just be careful. Again, some people have done this before. Don't multiply 4 and 2. Make sure you do the 2 to the power of 21, then multiply that by 4. Cool. I do like those shoes, though. Both of y'all.
I got something in my
So
socks.
sweet.
I don't know what's going on.
Yeah.
Thank you, though. Thank you.
Anything else on that, number 5?
Okay, so number 5, we just do the exponent first, then we'll multiply by 4.
Correct.
Okay, sweet.
Remember the term, the nth term versus the sum. That's the big thing.
Okay, sweet.
Okay, next one. Oh yeah. So 6 is a little weird. Okay, 6 is a little weird. Okay, so I would say this. On number 6, it says write the first 5 terms of the geometric sequence. Okay, so we only need 5 terms, right?
Do they give us 3?
They give us the third term, which is what?
2.
2. Okay. All right. Does that make sense so far?
Yeah.
To get to the fourth term, with r being 1/3, what would I do to get to the fourth term?
Add 1/3. Wait, no,
No,
multiply.
Multiply
because
by
geometric.
1/3. Good. And what would that change the fourth to? What's 2 times
2 over 3?
1/3? 2 over. That's literally all you need. Just 2 over 3. If I did it again to get to the fifth term, what would I do?
2 over 9.
2 over 9. Just multiply by 1 over 3. Okay? Now, here's where it becomes tricky. We got to go backwards, right? But if we multiply by 1/3 going to the right, good, which is really multiplying by the
3.
reciprocal, which is really 3. So what would this one be?
6.
6, and then this one would be
18.
18. Good. If you get stuck, the best thing to do is just say 18 times 1/3 times 1/3 times 1/3. Just to double check. Okay? It's not tough. It's just you got to kind of think a little bit.
Okay.
Okay?
I kind of like that one. It's tricky, but I like it.
Yeah, it's not crazy. Number 7. What one's this one? What are we gonna do on 7? Sorry, do you need that last one back?
Yeah, wait, where are those last ones?
You see that right there.
Okay, I'm ready now. We're good.
Okay, we're good. What type of formula would we use? Yeah, infinite geometric series, right? Exactly. So makes it easy that they gave it to us. So we just do S of n equals a1 over 1 minus r. If I didn't say this, another way to remember is that that dot 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 helps me in knowing where to go. Okay. What is a1? -6. The r is probably the toughest part. Okay. You see how -6 to 5, it's hard to know what I multiply by? Same thing here. But if you get that to where you see it where it's strange, look at the third to the fourth. 25 times what equals 125?
This is 5 over 6.
5, yeah. And then on the bottom you get 6, right? And so I would just say, and by the way, would it be positive or negative for r?
Positive.
Negative, good. And why'd you say that, Victoria?
Because it
Oh,
has
yeah,
to
yeah,
like alternate.
Back and forth between negative, positive, negative. So we would just say minus -5/6. Cool?
And then yeah, double those. You might want to add an extra cell in there.
That's right. That's right. Never could be too safe, right?
Yeah.
Here's what you did, just so you know. I mean, I'm gonna plug it in anyway to get that answer. But you did -6 divided by 1 minus -5 divided by 6. That's what you did. Okay. Problem is on your calculator, it does -6 divided by 1,
Yeah.
then subtracts by. That's why you got to do the.
That's why I need to do the second y equals or whatever.
Yeah, that's why you got to get this one over here.
Okay, sweet.
If you were to do it, or you could do the.
Because what does the parentheses just force it not to do PEMDAS?
Yeah, it basically because your calculator's not as smart
Yeah.
to do PEMDAS. Can't read what you want there. So you could do that and then press enter. You could also go ahead. The alpha y equals makes it extremely easy because then I just do -6 divided by 1 minus -5
So
divided
when
by
I
6.
do it like that, do I still have to do that extra parentheses, or will
No.
the calculator then process that?
Exactly, because it does this first
Okay,
and then
got
the
it.
top. Yeah, that's the weird part.
Wait, so do you want the answer to this?
I mean, yeah, be
Or do you
negative.
just want us to leave it? Oh, well, it says leave it fraction.
It does say leaving fraction, so
Yeah.
technically this would be plus because there is no exponent, so we
Yeah.
could actually do that one. And so we could go 6/6 to get common denominators.
Okay.
That would be, what is that, 11/6?
Yeah, that's what it says.
And then I could just flip this bottom to the top and say -6/1 times 6/11, and then I could simplify and go.
Got it. So that should be -36/11. You can't really like simplify that.
Correct.
You just leave it like that.
Just leave
If
it
I
like-
leave it like this form right here, will that be fine, or do you want me to go all the way? Like the -6/1 minus, or do you want me to go all the way?
You could go all the way, at least getting an answer. If it says given fractional form, go ahead with that.
Okay,
But if not, you could just give it as a decimal.
all right, sweet.
Be good. Cool. Are y'all gonna be doing anything in prom? Like helping out?
No.
Are you glad?
Last year, I think they get a lot of juniors to do stuff. Well, this year they have like some seniors hosting, but last year we both sang at prom last year, so
I remember
glad
that.
to like,
Yeah.
because like, and I didn't like it was cool, but like that morning we had to like go there and like
It was
rehearse,
me
and I
personally
didn't
wanted
like
to be
that.
there really
Why?
early because we had to rehearse there.
And then
Yeah,
like,
but why didn't you like it? Was it just?
oh no,
It was just kinda-
performing
we-
was cool,
we
but
were
just like having to do it
transporting back
like
and
that
forth.
morning, like I had to like, and like for them, she lives in Sugarloaf, so like, but like I live like 15 minutes from like Phipps and Lennox where it was, so it wasn't as bad, but it was like we had to go bang, 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 and then back, so it was kind of.
Yeah, that's a lot. That is a lot. Oh, plus you had a day off last year, so it wasn't like you were missing school.
Yeah.
Yeah.
Yeah, that makes sense. Number 8 is very similar to the one we already did. You see that?
Yeah.
What term? What one would you use for the formula?
Nth
Nth
term geometric.
term geometric. You've got your A1. You've got your R. What would be your N?
23.
23. Yeah. You see that? So just make sure you do exponents first. Should be good. 9 we've already done. Unless you feel like you need another one. 10. We expanded that. Kind of did that today in class
Can we do 11?
as well. 11. Find the sum of the first 30 times. Yeah, that's tough. Okay, so did I give you the square root one, or did I give you the top one?
You gave us the top one.
Okay, so
Will we have one like that square root one? Because if so, we need to do that. But if not, then I'm like, oh, you're fine.
I don't remember if there. To be honest, I don't remember which one. I'll say it's the same exact thing. So as I do the top one, I'll do the bottom one as we go.
Okay.
Cool. So it's actually somewhat easier, actually.
With the bottom
The
one?
bottom
The
one.
bottom one, it just looks like n to the radical 3. Is that
Just
what it is?
The
Almost?
G's
Mhm.
is
Square root of 3, yeah. It actually makes it easier. So like if we look at this, what is the is it arithmetic or geometric?
Where are we doing the bottom or the top?
We'll do the top one.
It looks like geometric. Let's guess.
now it's arithmetic. Wait, no, geometric.
No, arithmetic.
Why is it arithmetic?
It's plus -1/2.
Yeah.
Or minus -1/2.
Minus 1/2. Good. So the D is minus 1/2 each time. So we would have S of n equals n over 2 times a1 plus a sub n. Okay? N is easy because it already said it was 30. A1 is 1/2. And a sub 30 is just the 30th term. So we're just trying to find what the 30th term is.
Okay.
And we could find that by doing what? Whenever we don't know this,
You mean the in term? Is that what you-
y'all did it right on the quiz or test today. You remember? When you don't know the 30th term, go ahead and use the nth formula. Right?
Okay. Oh, I was right.
Term formula. So what would be A1 here?
1/2.
Good. What is N?
30.
Good. And what is D?
Negative.
Negative 1/2. Yeah. So this is 29 minus or times negative 1/2. Yeah, 1/2 plus. So 29 times negative 1/2 is negative 29 over 2. With 1/2 plus that.
It's like negative 14.5, so it's like 15, I think. Wait, no, it's minus. So it's 14.
Yeah, negative
Negative
14. Negative 14 there. So then I just plug negative 14 in for a sub 30
Okay, sweet.
plus 1/2 multiplied by 30 over 2, and there you go.
Got it.
Good. And that's how you find the sum of that. Does that help with that part? Victoria, do you want me to continue?
No, I'm just writing it down.
That's cool. Number 12 is the C1. That's really easy.
Yeah, that's all we have to do is plug that in.
Just know how to plug it in your
Okay.
calculator.
That's
it.
it.
I'm not going to have you do Pascal's triangle stuff like that. We did 13. We're good there. 14 is write a rule for the following sequence. That's the ones that are deaf. Do you remember those ones? Okay. They're actually not as bad now.
Definitely plus 8. That's all I can.
Okay, since it's plus 8, what would you do in order to find the nth term of the sequence?
So just plus 8. We're going to do.
Well, if I add 8, right?
Is that what we do? 8 in? Something like that?
Yeah, it's going to be very similar to that. This is where I would say for this, since it's pretty much it's an arithmetic sequence, isn't it? Because you add by 8. So just go ahead and use the formula. Just use the formula and plug it
Okay.
in. What's A1?
13.
Good. What's D?
8. Plus
Good. So yeah, you just plug 8 in and simplify. Okay. Now the next one may not be as obvious.
Wait, so when we do n, what are we plugging for n though?
We don't know what n is. They're just saying how to find the nth term, right? Kind of like
So
what
all we're
we're
doing is
doing.
just really writing the rule. So they only really want you only really want the equation.
Correct.
Okay.
Correct. It's basically the opposite of what you did on 13. Just going backwards. Backwards on that one.
And 13, just make sure it's the one where you plug in 1, 2, 3, 4, 5.
Correct.
Got it.
You can do that on the calculator too if you want to. What about the second one on 14?
It's just 2 to the n power.
Good. On the top, 2 to the n. Good.
Then
What-
times 3 on the bottom.
Say that again. I'm sorry.
Then times 3 on the bottom.
Yeah. So since we're multiplying by 3, what would I put on the bottom for that part?
3 to the n.
3 to the n. Good, both of you. Yeah, if I was adding by 3, that is 3n. That's the difference. So you would say on the top 2 to the n, on the bottom 3 to the n. It's not as bad when we got our stuff we've done already. 15, infinite geometric sequence. We kind of already did one like that.
Top is
Just negative 8 the whole time, right?
Yeah, negative 1's the A1. What's the R?
Wait, oh, I thought we were doing the second 15, my bad.
Oh, you could do that one. Yeah, this one here.
Yeah, I thought we were doing that one. I'm sorry. Go ahead.
Is that the one on y'all's?
No, it's the top one, but I don't know
Oh,
why.
wait, no, we did
All
it
the
first.
8 subtracted me. I don't know why.
Gotcha. That's cool.
This one is just times -2.
-2 on the top, and then what about the bottom? Good, yes. But this one, we're not trying to find like a rule. We're just finding the sum of the infinite geometric sequence. That's this one.
So A1
So A1 is -1.
Mhm.
Minus R. So what is our R? What would our R be?
What do you think? Nice, -2/3. Good. That's what we're multiplying by to get to the next one. Good. We kind of already did this one too, didn't we? Just simplifying, plugging it in. Good. Y'all are hanging in there. This is good stuff. We may hit on every one of these. Pretty good. I know it's a lot. Okay, we good for the next one?
Yeah.
All right. Hang in there. Expanding. What do y'all think on that?
Good.
5 times. I think we're cool.
Yeah. Remember that when we plug in, the big thing is just take your time through that.
Yeah.
That's one. I would say that one to last on that one. 17, you'll really like if I say find the 10th term of the sequence and I give you this equation. How would I find that?
Plug 10 for N.
10 for n. Again, be careful. This is the part when you plug in parentheses. I would say this might be one too where I just do PEMDAS myself and then just double check with my calculator.
Got it.
Okay. Same thing on the second one. Same thing. Expanding on number 19. I'll come back to 18 in a second. Do y'all feel good on the expanding part?
Yeah.
What would go in for B?
-2.
-2i. Good. 18, find a formula for the nth term of the sequence. Let's do this. Let's do the first one. I just want you to notice this.
Yeah.
Do the top real quick.
I know the bottom of the first one is N to the exclamation point.
You're exactly right. That's why I wanted to do this. Look, I multiply by 1, then 2, then 3 to get to the next one. That's an M. That's something that you say, okay, that is N exclamation point. Now, here's where it gets tough. If I plug 1 in, I get 1, right?
Yes. So it's N minus 1 exclamation point.
Correct. Because I go 1, if I plug in 2, I get 2, then 6. So I have to go back 1, and that's why A sub n equals N minus 1 exclamation on the bottom. That's pretty, just something to remember. You could even throw that on your formula sheet if you want. And then what's the top? Good. 3 to the power of n. Good. So we're just multiplying by 3. Good. I think we've only got a couple left, y'all. What is it? 2 more?
Yeah,
3 more?
should we do a number that? Yeah, we have like 3 more.
3 more?
We did not. Well, 19 we said was a cool one.
Good on that one.
Let's do
20.
We did 22 in class.
We did
I think.
22 in class. I've got it here.
Yeah. Oh wait. Yeah. Let me write that down. I don't. Is that the D that you're saying is 4 up there?
Yeah, the D was 4. I'm sorry, that's bad.
I'm just gonna write down the D and the A, and then I'll solve it when I
Number 20, we'll wrap up with that one.
go.
Perfect.
Okay. It says the sum of a finite arithmetic series. Okay, so we know the formula, no? We know what that is. So that would be S of n equals n over 2, a1 plus a sub n. Okay. The sum is 240. If the first term is 10 and there are 12 terms, find the value of the last term. All it is just going backwards.
Right.
So talk to me real quick. What can we plug in for what we see here?
Okay, we've got 240 in for SN.
Yep. Mhm.
240 in for SN. Then let's plug in 12 for N. Is that
Great. Yep. We
12
got these
over,
two.
12 over 2. Then the first term is 10, so A1 is 10.
Good.
And then all we have to do is find the last term.
Yep. And that I'll label that as X as the part that I'm trying to find. Okay. So then you just 12 divided by 2.
6.
6. Yep. What do I do with that 6?
Subtract it. Or divide
We
it.
can divide it. Good. So we can divide by 6. That's good because it's being multiplied. I like it, Victoria. So we have 10 plus X on the right, and on the left side we have
40.
40. And then we get X by doing what?
Is this when we subtract X?
That's
I
where
mean,
we subtract by 10, yeah. Because we do the kryptonite or the opposite of what's being done. So that last term is what?
30.
30. Yep.
Sweet.
Y'all, hopefully that helped you if you're watching the podcast. And yeah, have a great one. Happy studying. Bye.